Hi. The algorithm that we are studying today is called linear search algorithm. It is one of the simplest and most used algorithm in the category of searching algorithms. Let's just understand the example first, how it works from a real life example. Let's say you want to look for a page number of a chapter in an index of a book. How do you do that? You start from the first chapter and move on to the next till you find the chapter that you're looking for. In the index sheet, you start from chapter 1, you see the page number, that is not what you're looking for, you move on to the next chapter. That way you keep on looking until you find the chapter that you are looking for. The same logic is used in linear searching algorithm. In linear searching algorithm, you have two inputs. One is an array or list, basically a collection of elements that you have, and the value that you are looking for. You can call it as a target. How linear search works is basically it will start at one end and goes through each element of array / list, whatever you're using, until the target is found. For example, let's see, we have this array of length 15. Index starts from 0 to 14. The linear search algorithm is also called a sequential search algorithm because it follows a particular sequence. It moves one by one in a sequential manner. So because it follows the sequential manner, we also call it a sequential algorithm. Let's say we are looking for the value 99. How it will work? It will start from the index 0. It will match the value 10 and 99. If they are same, it will return the index 0. But in this case, we have the value 99 and the value is 10. So it will move on to the next index, that is 1. It will match 7 and 99. They are not equal, so it will move on to the next. That way it will keep moving from 0 to 1 to 2, 3, 4 and 5. When it reaches 5, the value 99 and 99 they match. So it will return the index 5. So basically, we are traversing the list from one end to the other end and comparing all the values that we have in the array. Let's take some other example. What if we take the value, let's say 7. So for the 7, it will start from 0, it will match the index 0, then it will move on to 1 and the value will be found at index 1. What we need to count here is the number of comparisons that we are doing. So let's say in this case index 5, we did how many comparisons? We did 6 comparisons. We compared with 10, 7, 2, 3, 11 and then 99. So in 6 comparisons we found the target value. In case of 7, we did 2 comparisons. What if the case is 77? Let's say we are looking for 77. So for 77, we'll start from index 0, then we move on to 1, 2, 3, all the way to the end, index 14, where we find the element 77. So it will return the index 14, and the number of comparisons we perform would be 15. So it will take 15 comparisons to return the index of the element 77. That's how we derive the complexity of our algorithm. So in this case, the time complexity is basically the time it will take to complete the search of a value. Let's say if you're looking for 9, it took 6 comparison. So every comparison is 1 unit time. So we'll say it takes 6 units of time. So in case of, let's say we have an array of size n, then what are the chances? What is the time that it will take to calculate to find the value? So in the best case, it could be O of 1. Basically, it may find the element in one comparison only. Let's say if you're looking for 10, it will be found only in the first comparison. And what would be the worst case that we have for 77? That it will have to compare all the elements in the list. So it will take big O of n. So in the worst case, it may take O of n time that it will have to compare all the elements. In the best case, it can take O of 1 time only. What is the auxiliary space that we're using and what is the space complexity? To understand these more, we'll just go ahead and see the algorithm. So there are two approaches to implement the linear search algorithm. The first is iterative approach. By iterative, we mean we move on to the element one by one using an iterator. Like say we use for loop or while loop. So in this algorithm, we have a method linear search. It takes two inputs, the array and value that we're looking for. So basically it will start with a for loop. It will iterate the array for all the elements. It will compare all the elements with the value that we are looking for. If we get that value, if the value matches, we return the index of that element. Otherwise, we return -1. We'll take an example. Let's say we look for element 100. So when we look for 100, we pass the values array itself, that we have this, and the value as 100 to the method. The method will look for all the elements. It will start a for loop starting from index 0. So basically it will have an index, value and match. So index is 0, 1, 2, 3, 4, 5, 6, 7, let's say. The values are 10, 7, 2, 3, 11, 99, 72 and 100. So what are we looking for? 100. The value that we are looking for is 100. So on 0th index it does not match, on 1 it does not match, on 2 it does not match. That way it keeps on moving until we find the value where it matches with our value. So there's a match, so it will go in the if will be succeed and will return the index of the element. So index is 7. So the return index is 7. What if we look for value, let's say 23? So it will give the input as array that we have here and the value 23. So it will start comparing 23 for all the elements starting from index 0 to all the way 14. So it will compare from 10, then 7, 2, all the way. But when it reaches 14, it finds that there is no element. So the for loop will be completed with the length 14, but it did not satisfy, the if condition is not satisfied for any of the values. So it will return -1. So in this case, we get -1 as a return value. One more point we need to understand in linear searching algorithm is that, as in this pseudocode you can see, we are returning -1 when we have not found the element, but also we are returning the index of the element when we find the element. So what if we have an array like this where we have 6 values, 10, 33, 11, 97, 11 and 176. So we start searching from 0 and we go all together to the index 5. So this is 0, 1, 2, 3, 4 and 5. So let's say we're looking for element 33. In that case, it's fine. We submit the values array that we have and 33. It will start looking from the index 0, 1, 2, 3, 4 and 5. On index 0 it gets 10, on 1 it gets 33, on 2 it gets 11, then 97, 11 and 176. But on index 1 only it finds the value, there is a match, it will return 1 as my output. But what if I'm looking for value 11? In that case it will submit array and 11. But now here we can see there are two 11s in this particular array. The which one we are looking for? Are we looking for the 11 at index 2 or are we looking for an 11 index at 4? The linear searching algorithm works in this way that when it finds the first value, it will just return. So we start from this end, it will return this 11. So it will return index 2 because if it will compare 0, then 1, then 2 and it finds the match, it will return. But if we start from this end, what if we start from 5, then we reduce the index 1 by 1, then it will return this 11, the index at 4. So we use the linear searching algorithm. We are looking for single element. So here we have mentioned few things that we need to remember. In linear searching algorithm, first, the list is unordered. The list is not sorted. It could be in any random order. The time complexity is O of n for the iterative approach, because in iterative approach we are traversing from 0 to n to all the elements. That's why the complexity will be O of n. Then we move on to the next thing. What is the space complexity? The space complexity includes two elements. First is auxiliary space and then space complexity. The space complexity is basically size of input. Basically, the space you took, the space your program will take to store the input as well as plus the auxiliary space. Auxiliary space is basically the variables or any data structure that you use within the program to calculate the output. So like in this case, the input is of size n that we have here given. So that will be n plus auxiliary space. So in the algorithm that we are using here, we're not using any variable at all to store any values. So basically, we are just comparing the element of that particular array with the value. We're not storing any other values in temporary variable. So this will be 0. Or in some case, where for iterating the for loop, in case you use the variable to get the size of array, then that will be 1. So space complexity will be n plus 0 or 1 based on the way of implementation. In our case, it is 0. So the space complexity will be of n also. So the space complexity as well as time complexity is of n. And we need to remember it will always return the first occurrence. So it does not handle multiple occurrences. Let's understand one more thing. Where it can be used. We can use the linear search algorithm in one-dimensional as well as multi-dimensional arrays. But when do we use it? Do we use it in whenever we are looking for any element, or is there any particular condition when we can use it? We should use this algorithm only if we are looking for few elements, maybe 1 or 2 elements, not a lot of elements. In case if we have a big list, let's say of size 1000, let's understand from an example. Let's say you want to search for a contact number in a phone book for Oracle Corporation. Now we can start looking from the top, that is page 1, where the contact from the alphabet A starts. Then move on to the next page, and then we move on to the alphabet from A to N. Then we reach to the alphabet O, and in that page we start looking for Oracle. That could be one way, but we understand that it will take time. It's a time-consuming process. However, what we would prefer, if we can directly go to alphabet O and then start looking there, that would be better. So if the size of input is really large, then linear search algorithm is not the most efficient algorithm to work with. What we want to skip some elements and go directly to the element that we are looking for. So that's why we need the better category of algorithm. So here we studied the sequential algorithms, but the next category of algorithms that we will study is called interval searching algorithm. We will study other algorithms to search element in a list that are more efficient. Thank you.